The Royal Gorge Bridge in Colorado is, it's given here that the Royal Gorge Bridge, there is a bridge in Colorado, rise, there is a bridge 321 meters above the Arkansas River. Suppose you kick a rock horizontally. So this is a bridge. Let's draw it. This is a bridge. So this is a river. So this is a bridge. So you just suppose you kick a rock horizontally. There is a rock here. It was kicked horizontally. So it will start to fall down following a trajectory, a curved path. It will start to fall down following a path called curved path. So this was the height of the bridge was above this is 321 meters. This is the height of the bridge is 321 meters. This is 321 meters. And suppose you kick a rock horizontally off the bridge, the magnitude of the rock's horizontal displacement. This is the displacement. The displacement is 45 meters from the base of the bridge. 45 meters. So it was kicked this way, and then it strikes this. The rock is here, so it falls down at a distance of 45 meters from the base of the bridge. So this distance is 45 meters, and this vertical displacement is 321 meters. So find the speed at which the rock was kicked. We won't find the initial speed. It looks like the same as what we did before, except the difference is the numbers. We are going to follow the same procedure. We will do the way we did it before. So we know that the vertical displacement, the horizontal displacement, that's given by V naught multiplied by time interval t. So the horizontal displacement is 45 meters. 45 meters is equal to V naught multiplied by delta t. Our target is we want to find this V naught. We are going to find, our target is we want to find, this is what we want. That is what's asked. Is what's required. So to find the horizontal speed at which the rock was kicked, we have to find the time taken first. We have to find delta t. So to find t, I can use the equations of uniformly accelerated motion. That is the displacement, the vertical displacement is given by, that is given by V naught yt, the vertical initial displacement multiplied by t minus 1 over 2 gt square. That's how we calculate the vertical displacement. But we know that this rock was kicked horizontally. It means it didn't have a vertical initial velocity. It was 0. So the horizontal displacement is now, the vertical displacement is now given by negative 1 over 2 gt square. So we know that the vertical displacement is negative 321. This is negative 321 meters because the rock is falling down along the negative y-axis. This is given by negative 1 over 2 multiplied by 9.8 meters per second square times t square. So simplifying this, 2 by 4, you get 4.9. So negative will cancel by negative. This negative will cancel out by negative. So that we will have 321 meters is equal to 4.9 meters per second square multiplied by t square. Now, to find t, we have to divide both sides by 4.9 meters per second square. Dividing both sides by 4.9 meters per second square and dividing this also by 4.9 meters per second square, we will get cancel out, or simplifying this by this, you will get t square will be, now t square is given by, then t square is given by the ratio of 321 divided by, we divide 321 by 4.9, then you will get 65.5. This is 65 5.5 seconds square. Don't forget that. Let me show you where this comes from. Meter divided by meter per second square. So this is over 1. So this is meter over 1 multiplied by reciprocate the second expression, that's by meter. So this meter, now this meter will cancel out by this meter, so that we will have second square. That is the unit of time. So taking the square root of both sides, we take the square root of both sides, take the square root of both sides. So T will be, T is given by the square root of 65.5. That is, T is given by 8.1 seconds. So the rock will fall, the river, 8.1 seconds after. So once we find T, it will be very easy to calculate the initial speed with which the rock was kicked. So we want to find the initial speed. That's V naught x. So take this formula. You just take this formula. We know that 45 meter is equal to V naught multiplied by time interval delta t. So 45, substituting the time, is equal to V naught multiplied by 8.1 second. So dividing both sides by 8.1 second, divides by 8.1 second, and divides also by 8.1 second. So 8.1 second by 8.1 second will cancel out. You just cancel this by this. So V naught will be the initial speed with which, the initial horizontal speed with which this rock was kicked is 45 meter divided by 8.1. That is, this is equal to 5.5 meter per second. If the rock was kicked at a speed of 5.5 meter per second horizontally, don't forget that it's kicked in the direction of x-axis, that is horizontally. So the initial speed with which, this rock was kicked is 5.5 meter per second horizontally, or along the positive x-axis. But at the instant it falls down, this speed will be decomposed. It will have two components, that is x component and y component. So that's all what we have.